share the PPT so that I will start the live streaming. A minute. Yeah, now it is okay. Is it visible? Is it visible to you? Is it visible to you? Students, is it visible?
Yes, sir.
Okay. Right. So last class we have discussed about the endopedons. Now we are going to talk about endopedons now. So today we are going to discuss about the endopedons now. So what are those endopedons are? Very first student, first of all, you try to remember those terminologies. Where if you are very elementary or this is the first time if you're listening these words means try to note it down in a with a pen and paper. Okay, then and try to utter once or try to pronounce once. Definitely it will be very easy. So now we will see what are the endopedons. You will see very first one is argillic. What is it called? Argillic endopedon. And second one is called Natrik endopedon. And third one is called Arcgic endopedon. And next one is called Candic. And later on it's called Sporadic. And next is Sombric. And next is Cambic. So what are those? Argillic, Natrik, Arcgic, Cambic, Sporadic, Sombric, Cambic. Okay. And coming next is Oxic, and next is sulfuric, very interesting one, and next is salic, and next is plastic, and next is albic, and next one is glossic, and next is calcic, and next is gypsic. From here you can see some similarities. You can see some similarities in these origins. These are pedons, and next is petrocalcic. Then you can see petrogypsic, and next one is called pragipan. Next is called duripan. Pragipan, duripan. So these are the different endopedons. So what are those? These are the different endopedons. First of all, if you're very first time or listening these words means try to utter once. Okay, what are those? Argillic, natric, argic, cambic, sporic, sombric, cambic, oxic, sulfuric, salic, classic, albic, glossic, calcic, gypsic, petrocalcic, petrogypsic, fragipan, duripan. Okay, students. So you want to be very clear what kind of words you are using. So this terminology, if a student coming very first time he is learning endopedons means definitely these words will be some alien type. But don't worry, once you understand the interior depth of this endopedons, it will be very easy. Very first one, we will see the what is the argillic. So one by one, you please. So this is completely, this origin is completely developed by the elevation. So elevation of silicated clays. So what are this origin is completely formed by the elevation of silicated clays, and you can see more and more fine clay was percolated in this layer, and you can see some skin layer curtains you can be deposited. What are those curtains? It will be like this, students. The curtains will be like this. So you can see some skin deposits. You can see some clay deposits will be on the pet faces, and sometimes you should remember one thing. It should be clay content should be very high. How much means it should be one way? It should be the clay content. It should be at least 1/10 of the overall layer horizons. The clay content should be how much? If the both alluvial horizons have 180 centimeters thickness means it should be this argillic horizon should be at least 18 centimeters. This is the meaning of it. So it should be if it is a 180 centimeters thickness is there means by combining all these things this should be at least 18 centimeters. This argillic should be 18 centimeters. So naturally, students, it is very greater than the B horizon. It is 1.2 times. Much clay content will be there. Some margin 3% of clay will be there, and alluvial layer has more than 50% will be there. So these are the measurable soil properties. So overall, what should you remember? This horizon was developed by the elevation of silicated enriched materials, and you can see some curtain faces. Some you can see some clay deposits on the pets. Okay, students. If the for instance it should be 1/10 of over layer condition. The thickness should be 1/10 over the other horizons. What are those horizons? If the alluvial origins, alluvial and alluvial Origins around 180 centimeters thickness means this argillic origin should be around 18 centimeters thickness. Please remember, you will get many questions on this endopedon. Coming to students, what is next one is called natric. You know, it is a high sodium dominated students. There will be high sodium. How you will remember? What is the formula for sodium? Na. Sodium is like this. You should remember like this. Okay. Sodium is a highly sodium clay enriched horizon with a columnar and prismatic structure. You can see all those things. Most in exams, what kind of questions you will get? The highly sodium dominated endopedon is. Sometimes they won't give this endopedon also. You should identify something. They will give some mixture of both endopedons, epipedons in the options. So you should be very keen and very perfect, very precise in your answer. So what is this? The high sodium clay enriched horizon with a columnar and prismatic structure is natric horizon. Natric means sodium dominated. So mostly it meets all the requirements, students. It is quite similar to the argillic, but only problem is that it has 50% more exchangeable complex saturated with the sodium and has more exchangeable magnesium, sodium, and calcium. So here the base saturation is very high when compared to the argillic. That is a major problem. And compare with the, so this is called the natric. Natric means it is a sodium dominated horizon. Okay, students. Coming to the next is Arcgic horizon. This is also alluvial horizon of clay, silt, and humus, but this horizon is formed directly under the plough layer, students. Why? Because of this origin, due to the continuous cultivation, this origin was formed. It has how much thickness it will be there? Around 10% thickness will be there, or sometimes you can expect more than 10. And you can expect some wormholes. Wormholes means some, the worms, the earthworms, etc. You can say wormholes by the volume. You can say around this 5%. So this horizon, this Arcgic horizon, was directly formed under the plough layer. Plough layer. We will represent as AP. Okay, students. This is regarding the Arcgic horizon. Remember the keywords. That is very important regarding these pedons. Okay, Arcgic means is also alluvial, but formed directly under the plough layer due to the continuous cultivation. Okay, students. It is around, sometimes it will be more than 10 centimeters thickness. This is regarding the Arcgic horizon. Coming to next one is called Sporadic horizon. Here also, this horizon, this subsurface horizon, completely enriched with sesquio oxides with or without iron. Okay, iron. Okay, there will be no, there maybe or may not be iron, but it is completely enriched with humus, humus. It underlies on O, AP, or E horizon. Or where it open, it either it will be underlays under O horizon or under AP, under maybe under plough layer, or even you can expect under the E horizon also, that alluvial horizon also. It may, what we can say, it is also sometimes it may satisfy the characteristics of umbric epipedon also. There are many specific limited dealing with it, like where is some limitations. What are the, when we deal with aluminum, iron, organic matter, and clay ratio, and weathering overlaying horizon is virginal cultivate. So due to this, when we deal with these things, so sometimes it may reach up to the umbric epipedon. In general, where it forms, what is the climatic conditions required for this? You have to get the cold and humid regions are very important. Okay, and we are sometimes you can expect some sporic material, and it is more. And keep remember, students, this sporic horizon may not be comes under AP horizon. Don't confuse. AP means plough horizon. Don't confuse with, this is not a plough horizon. Mostly this horizon very rarely observed in India. The so-called podzols reported mostly where podzols will come. Podzols means podzolisation. Okay, where it occurs? Mostly in Himalayas, and it requires almost it requires of podzic horizons and lay down under the soil taxonomy. So due to this podzic characteristics, where due to the podzic characteristics only, we will recognize this horizon. So regarding this sporic horizon, you should remember only one thing. So here you can see some dominance of podzols. Podzols sometimes it may have sesquio oxides, enriched with sesquio oxides. You know what is mean? You should just link this horizon with the podzolization. Then you can understand what is the main theme of this sporic horizon. So now coming to the next is called Sombric horizon. Sombric means a free drain horizon located under the albic horizon. We will see what is albic horizon, etc. As a dark color and a base status looks like umbric. What will happen actually, due to the heavy level of humus, neither associated with aluminum and humus in the pods will not appear by sodium and common natric horizon. Actually, in the sodium, you can see some color variations. It will be very dark in color when compared with upper layers. And it is very dark in color. only you can compare with this because it does not have ICEC or clay contain a high base saturation like Natrik origin. In Sombric, we can say it's a pre-drained origin, naturally located under the Albic origin. Its colorness is very dark. These are the key points you have to remember. These are the color is very darkness when compared. Coming to the next one is called cambic origin. See, this is cambic origin. It is mostly this is formed due to the some physical and chemical alterations. Due to the physical alteration is weathering, chemical and physical weathering, this origin may form. What will happen means the material sometimes it will go pedogenic process. The material enough to form some soil structure may be formed, and if the texture was suitable, what will happen? Suitable texture was available in that particular climatic conditions. What will happen? It will liberate due to this physical and chemical alterations. You can expect some iron oxides will be liberated, silicated clays will be liberated, and original rocks of more than 50% volume. And even though due to this, the alteration was not completely due to this alteration. This physical and chemical alteration was not completely destroy the some volcanic glass. You can see the allopian glass also elsewhere because weathering was not happened very properly. The alteration was not happening. So it's a quite similar to the level of oxides and human clays. Though it has all these properties, but this cambic origin cannot be compared with argillic or sporidic origins. And also, students, we can see different the mineralogical composition. The mineralogy is highly variable because of the youthfulness, the youngness of this horizon. You can expect different due to the youngness of this horizon. And also, and this origin also you can find where the groundwater fluctuation is very high. If there is any groundwater fluctuation is very high, and you can see 50% more thickness, and due to this groundwater, you can see some evidence of carbonates and some gypsum components also you can observe in cambic origin. So what are the things you have to remember in cambic origin? This is formed by the physical and chemical alteration. This origin was completely formed by the physical and chemical alterations are formed. And mostly you can see wherever the some fluctuation in groundwater, we can find this cambic horizon differentiation. So this is the thing you have to remember regarding the cambic origin. And another one is called, students, candic origin. K. It's a both only just one letter was changed. You can see this is the subsurface low active clays. We can see you can't expect with or you can't may or may not be expected some clay depositions. And these are the measurable characters, students. What are those? The C's should be more or equal to 16 centimoles per kg, and the pH should be around 7. And the effective CEC or ECEC. What is meaning of ECEC? You should say what is the meaning of ECEC. It is around more or less 12 centimoles per P plus kg. Please, after completion of class, you should explain what is the meaning of ECEC. Okay, it shows a clay content increases up on the upper boundary. You can see because it was there is no that much problem. We have mentioned without clay, and clay content will be more than 1.2%. If with vertical distension, it will be more clay will be there, and less than 15 centimeters. We can say abrupt textural boundaries. You can easily distinguish the textural classifications, and you can't expect any stratification, coarse layers, all those things. So overall, students, we can remember for examination or for your idea, we can remember this. It has a very low active clays with or without skin. These are the things, and these are the measurable properties. It's very hard to difficult I remember, but you make some idea regarding this measurable soil properties. Coming to next one is called oxic. This oxic is enriched with iron, aluminium, and completely dominated with 1:2 type of clay mineral. This is the key point regarding with this, and these are the measurable soil properties here. So whenever you oxic horizon was came into your mind means you should remember those are the iron and aluminium oxides and dominated with 1:1 type of clay minerals. So, and from where silica is completely leached. So it was completely deposited. It's oxic origin, you can see. And these are typical characteristics. The CEC is around 16 or less more centimole pK, and pH will be 7. An effective CEC of 12 centimoles and P plus K. So you can see that the increase in clay can gradually than candic horizon. It contains less than 10% weatherable mineral and in fine fractions. So naturally there are highly weathered soils we can find in oxic horizon. So what are the keyword you have to remember here? These are enriched with iron and aluminium. That endopedon is called oxic endopedon, oxic horizon. Coming to next one is called, students, sulfuric horizon. Naturally, students, this type of horizon you can see where the soils was completely affected with acid sulfate soils, which you learn in problematic soils. I hope everyone knows acid sulfate salts. Naturally, these acid sulfate salts are very quite common. We can see you can encounter many acid sulfate salts in districts in states of Kerala and in Uttar Pradesh, some parts of Uttar Pradesh, even in Pondicherry also. Then and there they're rare but not officially recognized. Practically, I have seen some soils. So in sulfuric organ. So what is this? It's a mineral organic soil horizon 50 centimeters more thick. The pH will be less than 3.5, less than or equal to 3.5 when it was tested under the 1:1 soil water conditions. And it is highly toxic students because if the sulfuric acid content will be very high in this origins. Mostly this in the origin formed under this the parent mineral will be what how it will be? It will be some sulfidic material will be there. Acids, iron sulfates will be there. What will happen? This when this was exposed to the outer environment, the sulfidic material will convert it into sulfuric. So naturally, what will happen? There will be a lot of problems. You can see some foul smell. You can see engineering structures will be destroyed. So a lot of problems will be there. And also, when you dig a profile, you can see Jurassic concentration. Jurassic concentration. These are the concentration. You look some coloring conditions. We can see some oxides. We can see these are all the oxide conditions. We can see these coatings, these Jurassics. You can see a lot of yellow color Jurassics. We can see all this. Okay. This is regarding sulfuric acid, and you will read sulfuric origin and sulfuric sulfates, acid sulfates, etc. You will read in particular in a lecture. Coming to the next one is called salic origin. Here you can see some secondary accumulation of water. You can see some secondary accumulation of soluble salts. Don't confuse with the sodic, that is different. This salic is different. So here you can see some secondary accumulation of soluble salts of sodium chloride, sodium sulfate, and depth of soil profile. Origin is around this around it should be around 50 centimeters with secondary soluble salts over 2%. And the salt content and the what are the measurable soil properties? So if you see the salt content of electronic conductivity in saturation paste should be around 30 decisiemens per meter, and the product of EC normally decisiemens of thickness at more than centimeter. So overall, you should remember the EC is around 30 decisiemens per meter. That means there is a dissolve of highly secondary accumulation of water. So our secondary soluble salts will be more in salic origin. This is the key word you have to remember. Salic origin means secondary accumulation of water. Okay, students. Coming to next is called albic horizon. Actually, this is the albic horizon. It's formed because of bleaching of E horizon of podzoles and planoles. The typical color value. These are the measurable properties. 5 or more, and the color largely implies the clay and free iron oxides having removed from the horizon. So what we can see in the albic origin is this: due to the removal, all the iron oxides complete, all the clay color, the color implies that clay and other free oxides completely removed. That's why albic origin looks like this. It looks like this. You can see because all the porzels, everything was gone. So generally it occurs below the A horizon, sometimes under the albic horizon. Under the albic origin, there is a argillic or candic or sporadic or cambic origins or a fragipan. Sometimes under beneath this albic origin, you can expect these origins. So this is remember this regarding this. Remember albic origin in this context. Okay. So naturally it lies between. Sometimes you can expect some between argillic and candic also and fragipan. It lies between also. Sometimes it lies between sporadic and argillic origin also. It will be some difference. All those things. So this is regarding the albic origin. Coming to the next one is glossy origin. Glossy origin shows the albic origin characteristics gradually enduring an argillic or candic and natric origin. Sometimes it will show some properties like that. Naturally, it was developed. How these glossy origins are developed means because of degradation of argillic, natric, or candic origin, from which clay and free ions or oxides are removed. So how this clay? What are the key point you have to remember in here? In glossy origin, you have to remember when the argillic, natric, and candic origins are degraded. Degraded means all the clay oxides are washed out. Then you can see result of this glossy origin. This is the reason. And regarding the measurable soil properties, these are it is around 5 centimeters more thick, consisting of a alluvial part, which consisting of 15 to 80% of by volume of glossy origin and alluvial part also. You can expect these are the measurable soil properties. These are the data measurable soil properties. So overall, students, regarding glossy origin, you have to remember these is found by degradation of algilic, natric, and candic origin. This is regarding the glossy origin. Next is calcic origin, an alluvial origin, which is with a secondary accumulation of calcium and or magnesium carbonate, which are enriched materials. Naturally, it will around 50 centimeters thickness. It will be. This is regarding the calcic origin. These are the measurable soil properties. You can expect or less than, you can expect some 5% or more carbonates under the underlying origins beneath the layers. So calcic origin, the word itself which says that it is the alluvial origin with secondary calcium and or magnesium carbonates enriched materials. This is regarding the calcic origin. Remember, this keyword is very important. Coming to next one is called gypsic origin. Gypsic, actually it is all secondary accumulation of calcium and magnesium sulfates. Remember, that is quite this make a sense in the previous slide. Enriched materials, it is more than 15 centimeters thick and consisting of 5% of more gypsum. Here the gypsum will be there. Contain sulfates. That's why you can see gypsum. In gypsic origin, calcic origin is different. The accumulation of secondary calcium. But here you can expect some gypsum, accumulation of gypsum. Petrocalcic, it is enduring calcic origin cemented by carbonates with or without silica. So it is also accumulation of carbonates only, students, but it may be with or without silica. How much silica may present or may not be present in this particular horizon, but it is accumulated by carbonates with or without silica. But the thickness around it will be 10 centimeters and hardness will be 3 or more. In my dry fragments break down into acid but not with water. So what will happen if you want to break these fragments? We need an acid but not with a water. This is regarding the petrocalcic. The next one is called petrogypsic origin. These are the strongly cemented indurated gypsic origin whose dry fragments do not slaking. Slaking means that you can't see any slaking. So the origin is centimeters or more thick as percentage or more gypsum content. Product is thickness. These are the measurable soil properties. Thickness and gypsum content is around more than 150%. So gypsum content is very high, but this petrocalcium, you can't see any slaking in the water when you dissolve it. These particles, these rocks. This is regarding the petrogypsic. And coming to next is called classic origin. It is a thin layer, students. Very thin layer, permeable, dark reddish brown to black color plane. It's a very thin layer that's cemented by the iron and organic matter. Lies within 50 centimeters or 50 centimeters of surface. It has a minimum thickness of 1 mm. This classic is very thin, students. Very thin layer. It is hardly you can see like it will be hardly you can see between 15 centimeters only. Very thin layer, darkish red. It will be there. Very brown to black color plane. You can expect in this classic origin. Very thin layer. You need a very thin layer. Even you can expect very 1 mm thickness. It will be there. So this is regarding the overview of both epipedons and endopedons. These are the different keywords. Just remember all these things and remember all the keywords and concept. Definitely you can attend the questions very well regarding this lecture. So just to make these are the short points which I mentioned regarding the epipedons and endopedons. This will be helpful for you to understanding my entire presentation. This is a summary of this lecture. Anyhow, students, thank you very much for your patience in listening. Thank you so much. Very small class. I hope up to here we have completed 8 lectures. So hardly there will be another 8 or 9 lectures. We will end up this syllabus of pedology. Thank you very much, students. Thank you for patience. If you have any doubts, you can ask now.